Hi, welcome back to Moose and Chemistry. This is periodic table lesson number 2, oxidation numbers. What are oxidation numbers? Well, oxidation numbers represent the number of electrons given or taken when elements are combined to make compounds. Okay, so let's look at some of these oxidation numbers. Let's look at group 1 here. Group 1 will have a 1 plus charge, which means that it will give up 1 valence electron. Group 2, on the other hand, it will give up 2 valence electrons. Group 13 over here will give up 3 valence electrons. Group 12 will give up 2 valence electrons. And group 11, well, they'll give up 1 valence electron. Hey, look at this in group 14. That's carbon's group, right? They will either give up 4 valence electrons or they will take on 4 valence electrons. Group 15, that's nitrogen's group. It will either give up 5 valence electrons or take on 3 valence electrons. And normally, it's probably be where they take on 3 valence electrons. Group 16, that will give up either 6 valence electrons or take on 2 valence electrons. And normally, it's probably going to be the -2 charge. Group 17, well, group 17 is going to either give up 7 valence electrons or it's going to take on 1 valence electron to be a -1. Group 17 has 7 valence electrons, and every element is trying to achieve an octet. So in reality, it's going to probably be the -1 charge because all they need is 1 more electron to get to that octet. So I would say -1. All right. Oh, look, I have a 0 there in group 18. Why is that? Because these guys are noble gases. All right, noble gases, guys, they're inert. They don't like to combine with anybody, right? Can you make a compound with noble gas? Sure, I'm making one right now, xenon tetrafluoride. So yes, that is possible to do that. But notice that I left out groups 3, 4, 5, 6, 7, 8, 9, and 10. The reason why that is, there are a whole load of exceptions there. For example, titanium is an exception. Vanadium's an exception. Chromium is an exception. Manganese is an exception. Iron is an exception. Cobalt is an exception. Nickel is an exception. Copper is an exception. Can you believe that? That's a lot of exceptions. Are there more exceptions than that? Well, sure. There's palladium and platinum. And gold is an exception. So is mercury. Mercury is also an exception. There are a lot of exceptions in this area. So what does it mean by an exception? Well, these are like cation B elements. They can have more than 1 charge. So let's look at titanium. How many charges can titanium have? Well, titanium can have a +2, a +3, or even a +4 charge. What about vanadium? Vanadium can have a +2, a +3, a +4, and a +5. What about chromium? Well, chromium has a +2, a +3, a +4, a +5, and even a +6. What about manganese? How many does that have? Well, that one takes the cake. That's got a bunch of them. It's got +2, +3, +4, +5, +6, and even a +7. Wow, are we going to have a lot with iron? No, we're not. We're actually going to just have 2. It's going to be a +2 and a +3 charge. What about cobalt? Well, cobalt is like iron. It's going to have a +2 and a +3 charge. Nickel, let me guess. It's going to have 5, right? 5 cents. Get it? Nickel, 5? No. Nickel's not going to do that at all. Nickel's going to be like iron and cobalt. It's going to have a +2 and a +3 charge. Wow, that's a lot. What about copper? We have copper there too. Well, copper is normally a +1, right? But copper can not only be a +1, but it can be a +2 charge. Oh my gosh, that's a lot. What about palladium? Well, we're going to draw an arrow this way because we're running out of space up there. So palladium could be a +2 charge and a +4 charge. What about platinum? Let me guess. It's got a bunch of charges on that? No. Same thing as palladium, +2 and +4. You mean even gold has an exception? Normally gold's a +1 charge, but it could also be a +3 charge. And mercury, well, mercury can have mercury 1 or mercury 2, right? So that's going to be a +1 charge or a +2 charge. That is a whole lot of exceptions. Are there more exceptions than this? Why, absolutely there are. You know, the board's getting kind of filled up here, so I'm going to quickly erase quite a few of these things so that we can gain some space here. So while you're taking this all in and I'm erasing, isn't it amazing how chemistry, even though you make a rule in chemistry, it doesn't always stick, right? It doesn't always stick. Because, see, chemistry is neither black or white, but it is very gray. A lot of things like, oh, this is the rule in chemistry, this is the way it's going to be. Well, then suddenly, hey, that rule's gone because we have an exception. Wow. So yeah, it can be confusing. But, you know, if we just take time and concentrate, we see that these things tend to work out. Okay, so now, let's go back and let's look at some more exceptions. This time we're going to be looking at exceptions in the P block. That's from groups 13 through group 18. That's the P block elements, right? So what exceptions are out there? Well, let's take a good look here. Carbon, believe it or not, it has an exception, okay? And so does nitrogen. Nitrogen has some exceptions to it. Phosphorus and sulfur have exceptions. What else has exceptions? Well, arsenic and selenium. Yep, they have exceptions. I know that tin has an exceptions. What about beryllium and antimony? Yes, they do. These guys have exceptions too. Well, it seems like just about everything's an exception. No, not quite, but there are a lot of them out there. Chlorine, bromine, iodine also have exceptions. Right, what are those exceptions? Well, okay, so let's do some more cleaning up here. A little bit more here so that we have more space to write with. And if you don't mind, I'm going to take away these circles here and numbers. All right, so now let's look at the exceptions that belong to these guys. All right, carbon, for example, can either be a +2, a +4, or a -4. Nitrogen, right here, can be a +1, a +2, a +3, a +4, a +5, but normally it's -3. Okay. Phosphorus. Phosphorus right here, right there, that can be a +3 or a +5, but normally it's a -3 like nitrogen. What about arsenic? Arsenic right here, guys. Arsenic is going to be a +3 or a +5, but normally it's a -3. Let's look at tin. SN here, right? Tin is going to be a +2 or a +4. Okay. What about antimony? Well, antimony, right there, SB, can have multiple charges too. It's going to be a +3 or a +5 or a -3. Okay. Wow, we're getting a lot done here. Trillium. Trillium, on the other hand, TE can have a +4, a +6, or a -2. Okay, Selenium, on the other hand, let's put that one over here. Selenium can have a +4 or a +6, but mainly a -2 is what it's going to have. Sulfur, believe it or not, it's the same thing as selenium. It's going to have a +4, a +6, or a -2. Now, chlorine, bromine, and iodine. What about these guys? All right, so these guys right here, luckily for us, they all have the same kind of exceptions. We'll put them way down here. So we'll kind of put these arrows here to make that like that. So this is going to have either a +1, a +3, a +5, a +7, or normally a -1. So those are exceptions. Okay, so what we're going to do is we're going to clean this up one more time, and I'm going to try to color in these exceptions because I think that would be a good idea. So let's get this taken care of here. We're just going to erase these all real quickly. But before we get any further, guys, it's important to know that the lanthanoids right here, guys, these guys right here, they have a +3 charge, and the actinoids have a +3 or +4 charge. So that's important also to remember too. So we're going to erase one more time here. And we're going ahead and we're going to color things in. So we're going to go ahead and color the exceptions in. I like to do that. Titanium, of course, vanadium, chromium, manganese, iron, cobalt, nickel, and yes, even copper. Okay, those are exceptions. I would like to also color in palladium and platinum. They will come down here. Those are exceptions here. Okay, we know that gold is an exception, so we'll color it, and so is mercury. Color that one in too. Hey, let's color in the exceptions of tin and lead. Those are colored in, those are exceptions. And of course, we know that nitrogen and phosphorus and arsenic and antimony are exceptions, or can be. So we'll color those guys in right there. We know that chlorine, bromine, and iodine are exceptions. It's looking pretty good. Yeah. And let's see, did we leave anybody out? I don't think we did. Oh, yes, we did. We left out carbon. So we need to do carbon, color carbon in. Yes. Can't forget carbon as an exception. Well, that looks like it's guys. So you guys be snarly, and we'll see you back here at Moosing Chemistry.